Hey there, A alpha, A beta, A gamma, A delta, B and C. Are you aware what these letters are? Well, yes, of course. I'm talking about the nerve fibers. So this is a short conceptual video that explains what is the relationship between the conduction velocity and the diameter of the nerve fiber. So first things first, we are all aware that greater the diameter, faster will be the conduction velocity through a nerve fiber. That's very well known to us. But then let's understand what is the reason behind it. Look, a nerve fiber or axon has cytoplasm, which is called as axoplasm. So when this nerve fiber excites, there is flow of charges, the flow of ions. Sodium influx happens and those positive charges are going to flow within the axon. Now, greater the diameter means lesser will be the axoplasmic resistance for the flow of charges, which means the charges can travel faster and that would increase the conduction velocity of the overall impulse. This is the reason why larger the diameter, faster is the conduction velocity. So A alpha having the greatest diameter or highest diameter and therefore the fastest conduction velocity. Now, what exactly is this relationship? Well, that is described by the very well known Hursh factor. The Hursh factor or the factor of 6, it says conduction velocity is proportional to or it is roughly 6 times the diameter. This is the factor of Hursh. So for example, let's say A alpha has 20 microns diameter and its conduction velocity is 120 meters per second. Of course, we are not looking at the units, we are looking at the numbers. So 20, 120 like that. So that's called as the Hursh factor, and this is applicable only to in the case of myelinated nerve fibers. So A and B type of nerve fibers to which this factor is applicable. What about the unmyelinated fibers? C fiber type is unmyelinated, and in the case of unmyelinated C fiber type, the conduction velocity is proportional again to the diameter, but it is proportional to the square root of the diameter. So this is the relationship between the diameter and the conduction velocity of an impulse through a nerve fiber.